This animation system solves a critical problem in computer graphics, making animations run smoothly regardless of hardware capabilities. The animation loop is the heartbeat of any dynamic visual application, constantly updating and redrawing the screen. Without it, we'd have static images. The synchronization occurs via requestAnimationFrame, which aligns callback execution with the display refresh cycle, commonly matching standard monitor refresh rates of 60 Hz or 144 Hz, meaning it tries to call our animation function exactly when the screen is ready for a new image. This hardware dependency creates problems because faster screens would make animations run quicker, while slower ones would drag them down. That's where this program steps in with its timing control system. The core functionality revolves around two key functions. First, handle time input manages the slider control, taking user input to adjust our target frame duration, that critical number determining how often we actually redraw, independent of the hardware natural rhythm. When you move the slider, it immediately updates both the displayed value and the internal target frame duration variable that governs our animation pace. Then we have the animate function, the workhorse of the application. It receives a high precision timestamp and first calculates how much time has passed since the last frame. Here's the clever bit. It only proceeds with drawing if enough time has elapsed according to our target duration. When it does render, it clears the canvas, saves the drawing state, then draws a rotating line from center outward using trigonometry for positioning. The rotation angle increments by 1 degree each frame, with overflow protection. It finishes by updating the FPS display and scheduling the next frame. The initialization sequence kicks everything off once the page loads. It sizes the canvas to match its container, sets up the initial FPS display, records the starting time, and fires up the animation loop. The main feature of this system lies in its separation of rendering frequency from hardware refresh rates. By controlling how often we actually draw, based on elapsed time rather than blindly responding to every animation frame callback, we achieve consistent motion across different devices. What you see here is the absolute essence of frame rate control stripped down to its bare minimum. Just a rotating line, an FPS counter, and a control to adjust the target frame duration. But this foundation supports endless possibilities. You could replace the line drawing with complex sprites, particle systems, or interactive game elements, while maintaining the same reliable timing mechanism underneath. The principles demonstrated here scale up to professional animation systems and game engines, all built upon this fundamental concept of controlled frame timing. This code is heavily commented with detailed explanation for every major section and operation, allowing you to study and understand each component at your own pace. The link to the file location is in the description. Let's scan the implementation. That's all from my side. Be well.